Okay, so this integral won't be that easy, I'll tell you that. There's a lot of things you can do. You can use the reduction formula, but we're not going to do that because that's cheating, and I don't think you should ever try to remember the reduction formula because it's not that useful. But what's more useful is to know how to come about this a little bit more of a natural way. Okay, well, you know that we can use integration by parts for sure, right? And you also know that secant squared x is equal to 1 plus tangent squared x. Okay, and then you also know, like I said, integration by parts, where we say u dv is equal to what? uv minus v, oh, 1 second, messed it up a little bit, v du. Like, we know these two things, so we can 100% use that to rewrite this integral. Okay, let's continue in green. So we're going to use secant squared x, let it be that, so we're going to 1 plus tangent squared x, and then have a secant x dx. And then we're going to say this is equal to what? We're going to say uv minus v. I always forget this. v du. Okay, so all we got to do is assign this integral its names. You know, I mean, assign its variables. What's u and what's v? Okay. So if we just let u equal, I'm just going to guess here. Well, I mean, I'm going to guess. So okay, you gotta let either u be secant x or 1 plus tangent squared x. And if you pick the wrong one, well, the problem gets harder. That's the truth, right? But let u equal secant x. Then du is going to be the derivative of secant x. And, okay, so I don't remember the derivative, so I'll find it right now. So I'm going to write this as 1. Okay, sorry, I'm messing this up. I don't want to confuse you guys. d dx of 1 over cosine x. And then that's the same thing, right, as d dx of cosine x to the negative 1. And then I can just use, chain rule and basic derivative properties. So we get negative 1 cosine x to the negative 2. And then the derivative of cosine x, which is negative sine x. So what do we get? Well, then we see that we have two negatives, right? Move myself. Sine x, cosine x. This is going to be sine x over cosine squared x, which is what? Tan x and secant x. There you go. And now I remember the derivative. So it was actually that. So it's good. Correct. Let me move myself up here. Okay. Well, we're not done. What's dv? Well, dv must be then 1 plus tangent squared x dx. So if we want to find v, then we integrate, right? So v is equal to the integral of 1 plus tangent squared dx. And then this we know is equal to the integral of secant squared x dx. Okay, there we go. And do we know the integral of secant squared x? Well, isn't the derivative of tan x? If we take the derivative of tan x, I'm pretty sure it is secant squared x. Right? So then we know that the antiderivative of secant squared x is just tan x. So we know that v is equal to tan x. Okay. So in other words, now we can rewrite this integral, right? So I'll write I'm just going to write secant cubed dx. Remember, secant cubed dx is the exact same thing as this guy, right? But now, since we identified what u and v and dv is, we can use all this information to make it an easier problem. So let me go in black. So u is what? U is secant x. What is v? V is tangent x. Okay, then minus v, which is tangent x, and then du, which is tangent x secant x dx. Ooh, that is not spelled correct. Secant x. And if you guys notice, I made a minor mistake. Don't forget your differential dx. Like, you can be marked off points for forgetting that. That's a big deal. You want to declare that for doing this stuff. And I did kind of break notation, but I wanted to break notation to make it easier for you guys in Calc 2 to follow. If you're not in Calc 2, you'd get angry at me for kind of breaking a little bit of notation. But no harm was done. Just, what's it called? Just don't forget your differentials. Okay. So basically, we're saying that this integral, all the stuff over here is equal to this, which is kind of nice, because now we can say that secant x tan x is minus, and then we see that there's a tangent squared, and a secant. All right. So in other words, what does a tangent squared become? Tangent squared x secant x. Is that not the same thing as a what? What do you see that as? So tangent squared. Right. Look at this. Tangent squared. Okay. So tangent squared, just isolate that by putting minus 1 on the other side. So we get secant squared x minus 1. That's the same thing as tangent squared. And then we just have our secant x on the other side. So in other words, now we have this integral, which is, I'm going to factor this in. So we're going to have secant cubed x, put a parenthesis around this, dx minus secant x dx. And look at this. This integral over here is the same integral as that one. What does that mean? Okay, so I'm going to call this secant cubed x integral I. So I is equal to secant x tan x, and then it's going to be minus I and plus negative, right? Plus the integral secant x dx. And then we know that's going to be what? Okay. So, sorry, let me actually show you guys the trick here. Since if you can identify that these are the same thing, you can put this I on the other side. And then we get 2i. Right? And then we have secant x tan x plus this integral. And like I said, this integral we should note by heart because it's such a hard integral to do, but you see it 100 times over. Okay. The integral secant x dx. It's always equal to this. ln secant x plus tan x. Okay. That's the integral. Right? Like, I'll probably have a video of this on my channel if you are confused on this, but I honestly recommend remembering this integral by heart and the tangent integral because you'll see these two integrals come up a lot. You won't see secant cubes come up that much. You won't see any cubes or squares come up that much, but you'll see a lot of secants and tangents in your journey calculus. Okay, well, since it's simple, we can literally write that right there. So we get ln secant. Actually, I have the electric pen. Why am I... Let me just drag that guy. There we go. So look at this. This is our, like, we're almost done. We literally have our answer. All we got to do is divide by 2. So if we divide by 2, then we get I by itself. And that is equal to 1/2 secant x tan x plus ln secant x plus tan x plus some constant c. Okay, and then what is I equal to? Remember we said I was always equal to secant cubed x. Like we just literally just gave it a different name for a good second. That's all we did. Look at that. You solved the problem. You solved it. Right here. Here you go. So it was a lot of work, honestly. But the main idea was to use famous trig identities, substitute, use integration by parts, substitute things correctly. Right? If you don't substitute things correctly, the problem will go even harder. So you should realize that, like right here, if you don't see it getting easier, then maybe go and call u something else instead of what you are calling it at that moment. And then after that, just try to be cautious. Like, look at that. You have the secant cubed x integral here, which means you can probably do something with it, right? Instead of, like, what you shouldn't do is just try to do it again and have this thing keep expanding. What you should do is give it a name and then let it cancel itself out. That's the trick of math. Giving things random names and letting them cancel themselves out. Okay, I hope this was helpful.